everyone. Welcome to 2021. We made it to the new semester. Yay! So for our warm-ups, we're going to do things a little bit differently this semester. Our warm-ups will be not multiple choice. We're going to start practicing some more open-ended stuff. We might sprinkle in some multiple choice here and there. But for today, what I want you to do is do this warm-up. So pause the screen, do the warm-up, and then you can unpause for us to go over it. Oh, right. So for this, we wanted to identify the population and sample. I'm going to highlight the population. In this one, it's U.S. adults. And then I am going to highlight in a different color, or use a different color to say this 515 randomly selected would be our sample. And then this would be the population. So for the next one, should be pretty similar. During the winter months, the temperatures outside can stay well below freezing to prevent the pipes. Ms. Starnes set the thermostat to 50. She wants to know how low the temperature actually gets. And so I'm going to highlight that temperature actually gets. That's going to be our population. And then a digital thermometer records the indoor temperature at 20 randomly chosen times. That's going to be our sample. And then this was the population. So hopefully you can see that the population is the large group that we're trying to learn about, and the sample is who we actually have information on, and what we collected, what data we collected from that group. All right. So for this activity, you're going to do Desmos of Beyonce in class. If you're not in class, then you can get some of the class data from this video and copy it down. You can also click the Desmos link in Canvas to see what the class data looked like yourself if you'd like to copy it from there. So go ahead if you're not in class and either go to Canvas to get the Desmos link and look at the class data from that, or you can just go ahead and start copying down some of this stuff so that you can get the notes. All right, so this is going to be from one particular class, not necessarily the one that you guys are in, but we have a couple of things to take notes on for today's lesson. So I want you guys to make sure you follow along with your red pen. To start, we are going to be looking at this phrase, average word length in your sample. And we're going to say that that equals X bar. Remember, we learned this symbol in the beginning. It's the mean from a sample. And then here we have our dot plot. I circled this dot right here. I just wanted to remind you guys that one sample of 5 words averaged to 5 letters. Actually, there was 5 samples that did that, but that's one, that circled value is one of the samples. And so each of these little dots is an X bar. So I can kind of label them like that. And, you know, you don't have to fill out your whole circle like that, but they're sample means. And then this mu is our population mean. So that's why we did that warm-up where we're looking at the difference between sample and population. And you can see here that this was not a random sample. It was the one that you guys circled 5 words and did yourself. And so we're going to call this high bias. Remember, the mean, this is the true mean, and the middle of this distribution of samples is actually a lot higher. So it's high bias. All right, we're going to keep going. Looking at number 4, this was a random sample. And if you look at the center of this distribution, it is pretty close to the actual mean. And so we're going to say this is an unbiased or low bias, because the mean of the sample equaled the mean of the mean of the population was the mean of the different samples. And so number 5, I want to highlight a word here. How did the dot plot compare? So like we said, one was correct and one wasn't. So this means were different, and then also even this second one had lower variability. And so I'm just going to circle this. True mean word length is mu, and we call this a parameter. So it describes a population. We've seen these words before, but we haven't used them in a while. So remember with number 7 here, oops, that should say about. But remember with number 7, that if we're looking to see 3.64, according to this set of data, is about here. Let's see, 3.2, 3.4, 3.6. So in there, and that fits right in line with the rest. And if we look at anything higher than 3.64, we definitely get higher than 5%. So remember, when we have greater than 5%, that equals no evidence. And then when we have less than 5%, then we'll have evidence. We call less than 5% like surprising, which anything that's surprising does give evidence. So we're not surprised by 3.64 according to our data, and so we have no evidence. Okay, a couple more things. This last one on number 8, hopefully you see that it has lower variability. And so what we're going to write down is as n increases, our variability will decrease. So here we had a sample size of 10, and it got less variability than when n equaled 5. All right, so hopefully some of that vocabulary is sticking, and if not, we'll write down some more notes on the back in your important ideas box to get a little bit deeper dive into it. So go ahead and start filling this in. We have 2 distinctions to make, parameter versus statistic. It's really helpful because a parameter describes population and a statistic describes a sample, which is great because the P's go together and the S's go together. Notice that we use a lot of Greek letters for the parameters, mu, sigma, and then P's on a Greek letter, but some people use pi, we don't. And then for the statistics, we use like X bar, S for standard deviation, and P hat. Remember, that's a P with a little hat on it. We did that when we did our Y hats too. So that little what's it called? Caret on top of the P is a hat. Another word for the statistic is a point estimator. So we use it to estimate the population. So I'm going to write that. Used to estimate the parameter, because the parameter we don't usually know. Since it's for a whole population, it's really hard for us to know what that is. And so we use a statistic to try to estimate the population. What you guys were creating with your dot plots today was something called a sampling distribution. So the sampling distribution is the distribution of values for the statistic for all possible samples of a given size from a given population. So I'm just going to go back and show you that with number 4. We're just going to label this as a sampling. It's part of sampling distribution for X bar. So each sample that we got was a mean, a sample mean. And so when we put them all together, that makes a sampling distribution. And we'll talk more about the difference between the different types of distributions as we continue with this unit. But when you put a bunch of samples together and calculate something from them, like an X bar or a P hat, then that creates a sampling distribution. When the average of your sampling distribution equals what you're estimating, That's called an unbiased estimator. And so typically means and proportions are unbiased, and then other things might be biased. And then the variability definition is that if we increase the sample size, we decrease the variability. So remember, I wrote that thing goes up, variability goes down, and we'll see the math behind that as we continue through with this unit. So why don't you guys pause this if you didn't get a chance to write it all down while I was talking, and then you can try to check your understanding and unpause to see the results. All right, so here are the answers. I just want to talk a little bit through it. Population is 200 chips, sample is 20. The parameter, we would use a P for the population proportion, a 0.5, and a statistic, we would say that is our P hat. So it's got a little hat on it. It comes from a sample. We have some evidence that less than half of the chips in the bag are red because when we took a sample of 20, we got less than half of the chips were red. So that could just happen by chance, or maybe Miss Lynn is being dishonest and just trying to pretend like she will give them extra minutes on homework, but she really won't. So she could be lying. Now we do a simulation of part of a sampling distribution. And so these are all different samples of size 200, assuming that Mrs. Lynn is telling the truth. And we had one sample right here where we had 80% of the chips were red. That's what that one particular, from the simulation, means. And so all these are different P hats. So we, like before, I wrote X bars. These could be P hats, P hat. Each of these could be a P hat. And so I'm just going to write part of sampling distribution of P hat. So you guys can see that what that would be labeled as. And so if you look, here is 0.35 right there. And we think that number might be too low, but if you look at 0.35 or less, like it says, or smaller, that doesn't seem to be too surprising. It seems like more than 5%. So I'm just going to write, looks like greater than 5%. And so we have no evidence. Remember, think about it like, oh, is that suspicious or not? And it's not suspicious, like you're not surprised by the results, so you have no evidence against the claim that Miss Lynn was making. Okay, so I'm going to let you guys zoom in a little bit more on that and write anything else down you need to, and be sure to check in Canvas for what to do next. Thank you. Have a great day.